So hello friends, welcome back to our channel Adamya Education. We are here with the second lecture of the chapter Trigonometrical Identities today. In the last lecture, I saw that one of the questions was not uploaded properly due to some network issue. So I'm going to start with that question itself to help you guys. So our first question for today is, we have to prove that the square root of 1 minus cos A by 1 plus cos A is equal to sin A by 1 plus cos A. So whenever you see such square root relations on either side of the equal to, in the case of trigonometrical identities, you have to keep in mind, or you have to check out which part of the fraction, whether the numerator or the denominator remains same. In the question over here, we can see that the denominator in both the cases, in the left hand side and in the right hand side, it is 1 plus cos A. That means this term 1 plus cos A will remain intact. It will not vanish. So we have to make any sort of changes accordingly. So let's begin. So first let us write the LHS. Square root of 1 minus cos A by 1 plus cos A. So in order to keep 1 plus cos A intact in the denominator on the RHS, if we multiply both the numerator and denominator by 1 plus cos A, what will happen? In the denominator, we will get 1 plus cos A into 1 plus cos A, that is 1 plus cos A whole square. And even after removal of the square root, we will be left with 1 plus cos A. Therefore, our denominator will be satisfied. And you don't have to think about the numerator after that. If the denominator is satisfied, the numerator will always be satisfied. One more thing that you have to keep in your mind is that whenever you're multiplying something with the numerator, you have to multiply the same term with the denominator as well, and vice versa. So we have multiplied 1 plus cos A on both the sides, on the numerator as well as the denominator. So let's see. So inside the square root, we have 1 minus cos A into 1 plus cos A plus B into A minus B. So 1 minus cos square A square minus B square. Again, I am telling you, if you have forgotten the identities, please make sure that you are recapitulating them very well, because they will be required extensively in this chapter. And in the denominator, we have 1 plus cos A whole square. Now the numerator, we have 1 minus cos square A, that is sin square A. And in the denominator, we just have 1 plus cos A whole square. We will keep it as it is. So 1 plus cos A whole square. Now if we take it out from the bracket, sin square A will, not from the bracket, I'm sorry, from the square root, we will get sin A. And in the denominator, we will get 1 plus cos A. This was asked in the question on the right hand side. So we have proved the left hand side with the right hand side. So is equal to RHS proved. So I hope you have understood how to solve such type of questions. Now let's move to another question out here. Over here we have another square relation, but out here we see that there is no fraction. So we are not going to follow our previous method. We are going to do it in a much more simpler way. It is a direct question. So let us see how to solve it. Alright. So beginning with the LHS, we have sec A plus cosec A. So sec A can be written as 1 by cos A, and cosec A can be written as 1 by sin A. So let us do that. Let us make those changes. So 1 by cos A plus 1 by sin A. Now we have fractions, so we can find out the LCM. The LCM is cos A sin A. And in the numerator, we have sin A plus cos A. So I'm extremely sorry for pausing the live session. The question which I just showed you a few minutes ago, that was wrong. That was not correct. The question was incomplete. So now I've changed the question. This is the actual question. So we are going to start from the beginning once again. Out here we have to prove that square root of sec square a plus cosec square a is equal to tan a plus cot a. This is our question. So let's see how do we do it. Let us begin with the LHS. So square root of sec square a plus cosec square a. So over here we see that in the right hand side we have relation between tan and cot, and we know that sec square a bears a relation with tan square a and cosec square a bears a relation with cot square a. So we are going to use that square relation. So in place of sec square a I can write 1 plus tan square a, because yesterday we saw that sec square a minus tan square a is equal to 1. Similarly, in place of cosec square a I can write 1 plus cot square a. Alright. Now I am taking the tan square and cot square together, and I am keeping 1 plus 1 2 on the right side. So tan square a plus cot square a plus 2. 1 plus 1 is 2. Now we know one thing, that tan and cot are just the inverse of one another. So tan theta into cot theta was 1. We just saw yesterday. So I can write it like this: tan square a plus cot square a plus, we have 2 into 1 over here. So in place of that 1, can I write 2 tan a cot a? Because we know tan a into cot a is 1. So in place of that 1 which was multiplied with 2, we can write tan a cot a. Why I am doing this? We can see that in our right hand side we want tan a plus cot a. And that is possible only when we have tan a plus cot a whole square inside a square root. So in order to bring tan a plus cot a whole square, that means a plus b whole square, I am using this term tan a cot a. So this is my a square, this is my b square, and this term becomes 2ab. I hope it is clear. So now I can write this expression as tan a plus cot a whole square, and we have square and square root, so it will just get cancelled out and we are left with tan a plus cot a, which was asked in the question. So it is equal to RHS. So the square relations are important, the identities are important. So whatever you have studied in the lower classes, you have also studied about trigonometry a little bit in class 9. So those previous knowledge is very essential for doing any question in this chapter. Let's move on to the next question. This is a very simple question. We have an MCQ sort of a question out here. So we have to simplify this expression and then we have to find which answer is correct, which option is correct over here. So let's begin. So we have tan theta into square root of 1 minus sine square theta is equal to which of the following options. So let's begin. So tan theta into 1 minus sine square theta. We know 1 minus square theta is cos square theta. So tan theta square root of cos square theta. In place of 1 minus sine square theta, I can write cos square theta. Now I can take it out from the bracket or from the square root. So cos square theta, square root of that will be cos theta. And now tan theta can be written in term of sine and cos. We can write sine theta by cos theta. And over here we had another cos theta. So they will get cancelled out and we are left with sine theta. So sine theta is our answer. Our answer is option number B. So this is one of the questions from sample paper, most probably of 2002. So this question is very important and very easy also. This is our next question. We have to prove that cos square a by cos a minus sine a plus sine a by 1 minus cot a is equal to sine a plus cos a. So let's see how do we do it. Let's begin with LHS because the LHS looks a little complicated. So cos square a by cos a minus sine a plus sine a divided by 1 minus cot a. So since in the answer, in the right hand side, we have sine and cos, so I can do one thing, I can convert this cot into cos and sine form. So let's do that. And I'll keep the first term as it is. I'll just change the cot A of the second term. So cos square A divided by cos A minus sine A plus sine A divided by cot A can be written as cos by sine. So 1 minus cos A by sine A. Alright. So in the denominator we have a fraction in the second term. So we are going to solve it. The first term will remain as it is because I don't think we can make any changes out here. It will just become more complicated then. So we have sine A divided by, if we take the LCM, we will have sine A as the LCM, and then in the numerator of the denominator, sine A minus cos A. Yes, sine A minus cos A. Alright. Now if we solve this, we will see that this denominator sign goes to the top. So in the numerator we will have sine square A, and in the denominator we will have sine A minus cos A. Your knowledge about fraction division is very essential if you want to solve these type of questions, because if you don't know how to solve division related to fraction, you will struggle with which term will go to the top, which term will remain at the bottom. So if you have forgotten those things, just go through that chapter once again for your quick recap. So we are left with cos square A by cos A minus sine A plus, over here we are getting sine square A divided by sine A minus cos A. Okay. So we see one thing, that in the denominators, one has cos A minus sine A and the other is sine A minus cos A. So if we want to make it same, we can very easily understand, if we change the sign of cos A out here, it will become plus cos A, and as a result this will become minus sine A. That means a minus sign is going out here. Basically we are taking minus as common, and then that minus sign is moving to here. That means in place of this plus now we will have a negative sign. So let's do that. So cos square A by cos A minus sine A minus sine square A by cos A minus sine A. So in this way we have changed the denominator to be equal. Both the denominators are now equal. That means the LCM will be cos A minus. I'm very sorry friends for the inconvenience caused. The previous live stopped abruptly. So we were doing this particular question, and for those who have joined right now, you can see that we have converted cot A into cos A by sin A, because our answer is in the form of sin A and cos A. So we have just made that particular conversion, and then we have simply solved it. Over here we had fractional term in the denominator. We have simplified it and we are finally getting sin square A by sin A. But in the first term our denominator was cos A minus sin A. So in order to make both the denominators equal, I have simply taken the negative sign from the denominator here as common, and I have converted this positive sign into negative sign, as you can see in the last step. So this is all what we did. Now let's continue. Since the denominator is same, I don't have space here. Okay, I'm just doing it here. You can copy it down and later I'll just rub it off. So our denominator is cos A minus sin A. So let me write cos A minus sin A, and in the numerator we have cos square A minus sin square A. Cos square A minus sin square A. So in the numerator we see that it is in the form of A square minus B square. If it was plus, we could have written it as 1, but over here it is minus, so it will be A square minus B square, that is A plus B into A minus B. So cos A plus sin A into cos A minus sin A. And in the denominator we have cos A minus sin A. So let's cancel it out. This will get cancelled. So we are left with cos A plus sin A. And this is what was on the right hand side. So is equal to RHS proved. So the questions related to proving in trigonometrical identities are very simple. You just have to understand by seeing the question where you have to begin or what changes you have to apply. Okay, now let's do the next question. I'm giving you like almost 10 seconds to copy it because just there are 3 steps and then we'll begin with this question. Alright, now let's begin with this question. This is a very interesting one, and in this question you will require identities. So you have sine cube theta plus cos cube theta divided by sine theta plus cos theta is equal to 1 minus sine theta cos theta. So over here we see that in the numerator we have a cube plus b cube form. Right? We know the formula, but for those who struggle with remembering formulas, there is a very easy way to remember or to find out rather. So let's see how to solve. So we know that a plus b whole cube is a cube plus b cube plus 3ab into a plus b. I guess you all know about this. So from this formula we are going to derive hello Gurlin. You have asked me to do some chapter-wise test series. Why not? Let me finish this chapter and then we will begin with some questions, or maybe I'll just upload a few questions related to the people who are going to give their board exams very soon. Okay, thank you for the suggestion. I'll definitely work on it. And if you haven't subscribed to our channel, please do, so that you get regular videos which will help you out for your long run. So we have a plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. Now we want a cube plus b cube. So I will keep this a cube plus b cube on one side and I'll take all the other terms to the other side. So we have a cube plus b cube is equal to a plus b whole cube minus 3ab, and inside the bracket we have a plus b. Okay. Now you see that in the first term and in the second term a plus b is a term which is common. So I can take this a plus b outside and I will be left with a plus b is common. So I'll be left with a plus b whole square minus 3ab. So let's solve the things which are inside the bracket. A plus b whole square, so a square plus b square plus 2ab, and we have minus 3ab. So we are getting a plus b into a square plus b square minus ab. So this is the expression for a cube plus b cube. You can either choose to remember it or you can also choose to derive it within less than 1 minute. I will definitely tell you that don't try to memorize things, don't mug up. Rather, it is very simple, and moreover, when you start doing such calculations, it will also increase your intelligence, your IQ. So this is our expression. So in place of a cube plus b cube, I can write this. So the same thing we are going to do in the numerator. We have sine cube theta plus cos cube theta in the form of a cube plus b cube. We can write it in this term, in this form. So let's do it. So I'm using a different color so that you can understand now. So our LHS is sine cube theta plus cos cube theta divided by sine theta plus cos theta. So in place of sine cube theta plus cos cube theta, I can write sine theta plus cos theta and then a square plus b square. So sine square theta plus cos squared theta minus AB, that means minus sin theta cos theta. And in the denominator we have sin theta plus cos theta. So this sin theta plus cos theta term can be cancelled out and we are left with sin squared theta plus cos squared theta minus sin theta cos theta minus sin theta cos theta. Okay, so sin squared theta plus cos squared theta is 1 and this can be written as it is. So 1 minus sin theta cos theta. So I guess this is what was asked. Yes, 1 minus sin theta cos theta. So is equal to RHS proved. So it's very simple. Only the condition or the criteria is that you have to remember the identities, or even by chance if you forget you can always derive it. So let's do another question. We have a few more questions. Okay, we have quite a lot of questions today. So we have to prove the identity sec A by sec A minus 1 plus sec A by sec A plus 1 is equal to 2 cosec square A. So let's do it. This is a very easy and direct question. So our LHS is sec A by sec A minus 1 plus sec A by sec A plus 1. Alright. So as we see in both the terms we have fractions. So let us take the LCM. Sec A plus 1 into sec A minus 1. And in the denominator we will have sec A into sec A plus 1 plus sec A into sec A minus 1. Okay, so let's multiply the terms in the numerator. So sec A into sec A is sec square A, then we have sec A plus sec A, plus again we have sec square A minus sec A minus sec A. And in the denominator we have A plus B into A minus B. So A square minus B square. So sec square A minus 1. So sec A and minus sec A is getting cancelled out. We are left with 2 sec square A. And out here we have sec square A minus 1, which is tan square A. The square relation which we have learned. Sec square A minus tan square A is 1. So sec square A minus 1 is tan square A. So we want in terms of cosec square A. So we will convert this sec square A into cos square A into 1 by cos square A and tan square A into sin square A by cos square A. So what do we get out here? 2 into 1 by cos square A divided by tan square A can be written as sin square A by cos square A. So this cos square A gets cancelled out and we are left with 2 by sin square A, or we can also write it as 2 cosec square A. So this is what was asked in the RHS. So is equal to RHS proved. So this was a very easy one. You did not have to do any such changes or transformation. I hope this question was clear. Let's move on to another question out here. This is also a very easy and interesting one. So let's begin. Alright, I hope you can see the question. We have to prove that sin A plus cosec A whole square plus cos A plus sec A whole square is equal to 5 plus sec square A into cosec square A. So let's see how do we solve it. So simply first of all we will start with our LHS because obviously it looks a little more complicated. So sine A plus cosec A whole square plus okay, how can we write it as cosec? Okay, so we have 2 by sine square A. That means we can write it as 2 into 1 by sine square A, and we know 1 by sine square A is cosec square A because sine and cosec are just the opposite, just the invert of one another. So in this thing can be written like this also. Let me explain. 2 by sine square A, we have 2 by sine square A. This can be written as 2 into 1 by sine square A. And we know 1 by sine square A is cosec square A because sine and cosec are just the invert of one another. So I can write it as 2 cosec square A. So instead of using this step, I am directly jumping from this step to this. You don't have to show this step, okay? You have to just do it in your mind calculation. Alright, let's get back to the question. So we have now cos A plus sec A whole square. Alright, so we have A plus B whole square plus A plus B whole square. So we have to simply just take it out from the bracket. So we will have sine square A plus cosec square A plus 2 into sine A cosec A plus B whole square. So A square plus B square plus 2AB. Similarly, now we have cos square A plus sec square A plus 2 cos A sec A. Alright. So we see one thing. We have sine square A plus cos square A, which can directly be written as 1. So let us do that. 1 plus this term 2 sine A cosec A. Sine A and cosec A are just the invert of one another. So sine A into cosec A is 1. So 2 into 1 is 2. Similarly, this term cos A and sec A are just the invert of one another. So cos A into sec A is 1. So 2 into 1 is 2 again. Now we are left with cosec square A and sec square A. We can convert it into terms of sine and cos in order to get this value. See, in the right hand side we don't have a plus sign between sec square A and cosec square A. So we have to do some transformation in order to bring this multiplicative term. So before that, let us just solve the things which we have got till now, and then we will leave it for the next time. So first let's write as it is cosec square A plus sec square A. So now we have 2 plus 2 plus 1, 5. We have got this first term. Now we are going to deal with this. Cosec square A can be written as 1 by sine square A. And sec square A can be written as 1 by cos square A. Now I will just consider these two fractions because I have got 5. So I am not going to do anything with it. So the LCM will be sine square A into cos square A. And in the numerator I will get cos square A plus sine square A. So we have 5 plus, we know cos square A plus sine square A is 1. So 1 divided by sine square A into cos square A. So this term can be written directly as sec square A into cosec square A because 1 by sine square A is cosec square A and 1 by cos square A is sec square A. So I guess whatever doubt you were asking, it's clear once again. The same thing we are doing here. So let me write the answer. 5 plus 1 by sine square A is cosec square A and 1 by cos square A is sec square A. This is what was asked in the question. So is equal to RHS proved. Alright. So I'm giving you a break of 2 minutes. Just drink some water, get refreshed, and then we will do the few more questions which I have in stock for you guys. So welcome guys once again. We have 3 more questions to be done and then I will give you your holidays which you have been wanting since long, because today we have done quite a good amount of questions. Okay, so let's begin. LHS, we have 1 by sec x minus tan x plus 1 by sec x plus tan x. So let's see. So 1 by sec x minus tan x plus 1 by sec x plus tan x. Okay, so we have fractions in both the terms, so we are just going to simply find out the LCM. The LCM will be sec x minus tan x into sec x plus tan x, that is a plus b into a minus b. So I am directly writing as a square minus b square, that is sec square a minus tan square a. Okay, now in the numerator of the first term we will have sec x plus tan x, and for the second term we will have sec x minus tan x. So we will cancel out this tan x and minus tan x. So we are left with 2 sec x by sec square a minus tan square a is 1 from the square relation which we have learned. So we are left with 2 sec x. But we have to prove that the RHS is 2 by cos x. So isn't it true that sec x is the opposite of cos x? So can we write sec x as 1 by cos x? Yes, definitely. So in place of sec x, I can write 1 by cos x. That is 2 by cos x. This is what was asked in the question. So we have proved it. LHS is equal to RHS. Now coming to our next question. We have to prove that tan square theta by sec theta minus 1 whole square is equal to 1 plus cos theta by 1 minus cos theta. So let's begin with LHS. The square thing looks complicated, so we are going to begin with that part. So tan square theta, okay, tan square theta by sec theta minus 1 whole square. So we can write tan square theta in terms of sec theta, right? We know that they have a square relation. So in place of tan square theta, I can write sec square theta minus 1. Because sec square theta minus tan square theta is 1. So tan square theta is sec square theta minus 1. And in the denominator, we can write it as it is sec theta minus 1 whole square. Okay, so in the numerator, you see you have a square minus b square form. Sec square theta minus 1 square basically. So a square minus b square, it can be written as a plus b into a minus b. So sec theta plus 1 into sec theta minus 1 divided by sec theta minus 1 whole square. So I can make some cancellations. This will get cancelled out with this. So we are left with sec theta plus 1 divided by sec theta minus 1. So sec theta plus 1 divided by sec theta minus 1. So I have to bring it in terms of cos theta. So simply we will convert sec theta into 1 by cos theta. So 1 by cos theta plus 1 divided by 1 by cos theta minus 1. So if I take the LCM of the numerator, I will have cos theta and 1 plus cos theta, and in the denominator also the LCM will be cos theta, but we will have 1 minus cos theta. So now I can cancel out this cos theta and cos theta. So we will be left with, I am writing it at the top. So we will be left with 1 plus cos theta divided by 1 minus cos theta, and this is what the RHS wanted. So proved. Just imagine from tan we are bringing cos. So it's very simple. You just have to remember the relations which we have learned, and then we can simply put it and solve it. So coming to the most awaited last question of our lecture today. So let's finish it off and let's end the session. So we have to prove that sine A by 1 plus cos A is equal to cosec A minus cot A. So let's see how do we do it. So we have cosec A and cot A. Do we see any similarity in between cosec A and cot A? We know that cosec A is 1 by sin A and cot A is cos A by sin A. That means in both these terms the denominator is sin A. That means we have to make certain changes in the numerator such that the denominator becomes equal to sin A. How do we do it? We have 1 plus cos A. If we multiply with 1 plus cos A, we will have 1 plus cos A whole square. It's not going to change anything because there is no square root, so it will remain as it is. But if we multiply with 1 minus cos A, what will happen? If we multiply 1 plus cos A with 1 minus cos A, what will happen? We are getting A plus B into A minus B. That means 1 minus cos square A square minus B square, and we will get sin A. So we can do this. We can multiply 1 plus cos A with 1 minus cos A, and since we are multiplying the denominator with some term, we have to multiply the numerator also with the same term. So as soon as we understood it, let's begin. Alright. So our LHS is sin A by 1 plus cos A. So we saw that we have to multiply it with 1 minus cos A in order to get sin A in the denominator. So 1 minus cos A will be multiplied both in the numerator as well as in the denominator. So sin A is multiplying with 1 minus cos A, and in the denominator we saw that it will be 1 minus cos square A. So sin A into, let's multiply it rather. So sin A minus sin A cos A divided by 1 minus cos square A is sin square A. Now what do we see? We have to bring it in this form. So we will just separate it. We will separate the two terms of the numerator in this manner. Sin A by sin square A minus sin A cos A divided by sin square A. Because we know if we have 1 plus 2 divided by 3, I can write it like this, 1 by 3 plus 2 by 3. I'm just separating it. We can again make it this because the denominators are same. So we can write it in the same fraction bar once again. So I have done the same treatment out here. So sin A by sin square A, we will get 1 by sin A minus sin A and sin square A is getting cancelled. So we are left with cos A by sin A. So 1 by sin A is cosec A and cos A by sin A is cot A. So we got what was asked in the RHS. So I hope today's session was fruitful to you and you have understood the questions which I have explained. Still, if you have any doubts regarding the session or if you have any other doubts, you can definitely mail it to us in the email ID which is provided in the description box. And hopefully we will conduct another live session of the same chapter very soon, and we will head towards learning heights and distances. And if I find some more complicated questions which might be beneficial to you, I will definitely try to bring it. So thank you for listening very patiently to my session and hope to meet you soon. Bye bye.